The man known to history as Nikola Tesla was born at the precise stroke of midnight between July 9th and 10th, 1856, in the remote village of Smiljan, nestled within the windswept mountains of what was then the Austrian Empire's military frontier, a region now part of modern Croatia. The exact timing of his birth would become the subject of minor dispute, as different records alternately list both dates, a seemingly trivial uncertainty that nonetheless presaged a life defined by contradictions between acknowledged genius and tragic obscurity. Local legend held that a violent lightning storm raged outside during his delivery, illuminating the night sky with electric fury, an omen that would prove hauntingly prophetic for a man who would dedicate his existence to harnessing the very forces of nature that heralded his arrival. Tesla was born into an ethnic Serbian family of modest means, but considerable intellectual pedigree. His father, Milutin Tesla, served as an Orthodox priest in the Serbian Orthodox Church, a stern but learned man who possessed considerable literary talents and harbored ambitions that his son would follow him into the clergy. Milutin was known throughout the region as both a gifted writer and a compelling orator, with an extensive personal library that would later captivate young Nikola's imagination. His mother, Duka Mandic, though unschooled and illiterate by formal standards, possessed an extraordinarily inventive mind and prodigious memory. She managed the family farm with remarkable efficiency and invented numerous household appliances and farm implements entirely from her own ingenuity, including a mechanical egg beater and various tools to ease domestic labor. Tesla would later credit his mother's inventive genius and eidetic memory as the true source of his own abilities, claiming that whatever talents he possessed were inherited from her practical brilliance rather than his father's bookish intellectualism. The Tesla household contained 5 children in total. The eldest, Dame Danilo, followed by 3 daughters, Milka, Angelina, and Mija, and young Nikola as the 4th child and 2nd son. By all accounts, Dane was an exceptionally bright child, perhaps even more gifted than his younger brother, and their parents placed extraordinary hopes upon his shoulders as the family's future. However, this promise would be catastrophically cut short in 1863, when Nikola was merely 5 years old, in circumstances that would haunt him for the remainder of his life. The tragedy occurred on an ordinary day that would become anything but. Dane, then 12 years old, was thrown from the family's horse in a riding accident of disputed circumstances. Some accounts suggest it was simply a tragic mishap, while others, including whispered rumors that persisted throughout Tesla's life, suggested that young Nikola may have inadvertently caused the accident by startling the horse with a blowgun or in the course of childhood play. Dane died from his injuries, and the family was utterly devastated. Tesla himself witnessed the fatal scene, an experience that traumatized him so profoundly that he later wrote, "The recollection of his attainments made every effort of mine seem dull in comparison." Whether Nikola bore any actual responsibility for the accident remains historically uncertain, but the psychological burden was unmistakable. The shock of his brother's death transformed the 7-year-old boy into what he would later describe as a mystic, plagued by vivid hallucinations and intense visions that he could not distinguish from reality. These visions would persist throughout Tesla's childhood and into adolescence. He described being tormented by blinding flashes of light, accompanied by elaborate mental images. Entire inventions would appear before his eyes, with such clarity that he could not differentiate them from physical objects. Initially terrifying, Tesla eventually learned to harness this peculiar ability, transforming what might have been debilitating hallucinations into a unique method of invention. He developed the capacity to construct entire machines in his mind, test them mentally, refine their mechanisms, and solve technical problems, all without ever touching pencil to paper or building a physical prototype. This extraordinary visualization ability would become one of his greatest assets as an inventor, allowing him to perfect complex machinery entirely within his imagination before committing resources to actual construction. The death of Dane fundamentally altered the family dynamics and Nikola's position within the household. His parents, consumed by grief, seemed to regard their surviving son with a mixture of expectation and melancholy comparison. Young Nikola felt the crushing weight of having to compensate for his brother's lost potential, while simultaneously grappling with possible guilt over the circumstances of the tragedy. This pressure would fuel both his relentless drive for achievement and the psychological peculiarities that would mark his later years. The Tesla family lived in a region shaped by centuries of conflict and cultural collision. The military frontier where Smiljan was located served as a buffer zone between the Austrian Empire and the Ottoman territories, a borderland populated by Serb military settlers who received land grants in exchange for defending the empire's southern boundaries. This frontier existence created a unique cultural environment, neither fully Austrian nor entirely Slavic, neither wholly Western nor completely Eastern, that produced individuals who existed between worlds. The Austrian Empire itself was a polyglot behemoth containing Germans, Hungarians, Czechs, Poles, Ukrainians, Romanians, Serbs, Croats, and numerous other ethnic groups, all governed from Vienna with varying degrees of success. The empire was experiencing the early tremors of the nationalist movements that would eventually tear it apart, though in the 1850s and 1860s, it still maintained an illusion of permanence and stability. The mid-19th century was an era of extraordinary technological and scientific advancement. Across Europe and America, the Industrial Revolution had transformed Britain and was rapidly spreading across the continent, bringing railways, telegraphs, and mechanized manufacturing to societies that had changed little since medieval times. In the United States, the Civil War was raging during Tesla's early childhood, while in Europe, the unification of Italy was underway, and Bismarck was maneuvering to create a unified German state. The foundations of modern physics were being laid by scientists like James Clerk Maxwell, whose equations describing electromagnetic phenomena would profoundly influence Tesla's later work, even as he began his education in a remote mountain village, far from the centers of scientific discovery. From his earliest years, Nikola exhibited characteristics that marked him as exceptional and troubling in equal measure. He possessed an almost pathological drive for perfection and became obsessed with counting everything: steps, objects, volumes of food. He developed powerful aversions to certain objects and materials, particularly round surfaces like pearls and the earrings worn by women, which provoked in him sensations of near-physical revulsion. These compulsions, which modern diagnostics would likely identify as symptoms of obsessive-compulsive disorder, grew more pronounced rather than diminishing as he aged. Simultaneously, he demonstrated extraordinary intellectual capabilities, devouring the contents of his father's library with voracious appetite and displaying a particular fascination with electricity and magnetism, phenomena that were only beginning to be understood by contemporary science. The boy who would grow to attempt wiring the world to lightning was thus forged in circumstances of tragedy, intellectual ferment, and psychological complexity. Born into a family of modest means but considerable intelligence, shaped by the traumatic loss of a brilliant older brother and possessed of mental capabilities so unusual they bordered on the supernatural, young Nikola Tesla emerged from the mountains of the military frontier, carrying both extraordinary gifts and profound psychological burdens that would define his revolutionary career and tragic later life. Tesla's formal education began at the Higher Real Gymnasium in Karlovac, Croatia, where he studied from 1870 to 1873. This institution provided a rigorous scientific and mathematical curriculum, far superior to anything available in his remote birthplace. It was here that Nikola first encountered systematic instruction in physics and mathematics, subjects for which he demonstrated such extraordinary aptitude that his teachers were simultaneously impressed and somewhat unnerved by his abilities. He could perform integral calculus in his head so rapidly that his instructors suspected him of cheating, unable to comprehend how a student could solve complex mathematical problems faster than they could write them on the blackboard. His memory proved equally remarkable, He memorized entire books, recited lengthy passages in multiple languages, and could recall with perfect clarity events from years past. However, this period was not without crisis. In 1873, having just completed his studies at Karlovac, Tesla returned home to Gospic, where his family had relocated. Almost immediately upon his return, he contracted cholera, a disease that ravaged the region and brought him to death's door for 9 months. Bedridden and wasting away, with doctors offering no hope for recovery, Tesla engaged in a desperate negotiation with his father. Milutin Tesla had always insisted that his surviving son enter the priesthood, but Nikola harbored passionate ambitions to study engineering. From his sickbed, in what he believed might be his final conversation with his father, Nikola extracted a promise. If he survived, Milutin would permit him to attend engineering school rather than seminary. His father, confronting the imminent loss of his only remaining son, tearfully agreed. Whether this promise alone provided the psychological will to survive, or whether Tesla's constitution simply proved more resilient than anticipated, he slowly recovered from the illness that had claimed so many others. True to his word, though clearly still harboring reservations, Milutin Tesla allowed his son to enroll at the Austrian Polytechnic in Graz in 1875, one of the 4 premier engineering schools in the entire Austro-Hungarian Empire. The young Tesla arrived with a military scholarship and threw himself into his studies with frightening intensity. During his first year, he was an exemplary student, attending every lecture, never missing a class, and achieving the highest grades in his cohort. He worked from 3 o'clock in the morning until 11 o'clock at night, Sundays included, prompting concerned professors to write to his father warning that such excessive dedication would kill the young man if it continued. Tesla studied far beyond the required curriculum, taking courses in 9 different subjects, far more than any other student, and achieving perfect marks in virtually all of them. It was during his second year at Graz, in 1877, that Tesla witnessed a demonstration that would fundamentally shape his life's work. His professor, Jacob Poschl, demonstrated a Grammon dynamo that could function both as a generator and motor using direct current. Tesla observed the sparking and inefficiency of the machine's commutator, the mechanical switching system required for DC motors, and suggested that alternating current might eliminate these problems. Professor Poschl publicly ridiculed the suggestion, declaring before the entire class that alternating current motors were a theoretical impossibility, tantamount to building a perpetual motion machine. Miss Tesla may accomplish great things, Poschl reportedly said, but he certainly will never do this. It would be equivalent to converting a steadily pulling force like gravity into a rotary effort. The humiliation stung deeply, but rather than crushing Tesla's ambitions, it ignited an obsession that would occupy his thoughts for years. However, this same period marked the beginning of Tesla's personal unraveling. He began gambling compulsively, initially winning large sums at cards and billiards, then losing them and more besides. By his 3rd year, he had stopped attending lectures altogether, dropping out without completing his degree despite his obvious brilliance. He concealed this failure from his family, who believed he had drowned in the Mur River when he failed to return home as expected. In reality, Tesla had fled to Maribor, Slovenia, where he spent a year working as a draftsman and assistant engineer while continuing to gamble away his earnings. His father eventually tracked him down and attempted to persuade him to return home, but Tesla, ashamed of his failure and unable to face his family's disappointment, refused. In 1880, after his father agreed to support him financially, Tesla moved to Prague to continue his education at Charles Ferdinand University. However, his father died that same year, and without financial support, Tesla was forced to abandon his studies once again, never completing a university degree, a fact that would later cause him considerable embarrassment when dealing with academically credentialed scientists. Nevertheless, during this turbulent period, the obsessive problem of the alternating current motor continued to consume his thoughts. Day and night he mentally wrestled with the theoretical challenges Professor Poschl had declared insurmountable. conducting thought experiments, and constructing elaborate mental models. The breakthrough came in February 1882, while Tesla was walking through the Budapest city park with a friend at sunset. He was reciting passages from Goethe's Faust, a work he had committed entirely to memory, when suddenly the solution appeared before him with blinding clarity. In a moment of revelation that would become legendary in the history of invention, Tesla visualized the complete design of a rotating magnetic field that could drive an alternating current motor with no commutator, no sparking, and unprecedented efficiency. Using a stick, he sketched the design in the dirt of the park path, a polyphase system in which multiple alternating currents, offset in timing, would create a rotating magnetic field that would induce motion in a rotor without any physical contact. This principle of the rotating magnetic field would prove to be one of the most important discoveries in electrical engineering history, the foundation upon which virtually all modern electrical power systems would be built. Armed with this revolutionary concept but lacking resources to build it, Tesla secured a position with the Continental Edison Company in Paris in 1882, designing and installing direct current power systems across Europe. His work demonstrated exceptional ability, and he distinguished himself by solving problems that had baffled other engineers, including successfully repairing a problematic Edison power plant in Strasbourg, France. During this period, he built his first working models of the AC induction motor, testing them in his spare time and confirming that his theoretical vision translated into practical reality. Tesla's supervisors at Continental Edison, recognizing his exceptional talents, encouraged him to travel to America, specifically to New York, where the great Thomas Edison himself was establishing his electrical empire. They provided him with glowing letters of recommendation, and at the age of 28, Tesla boarded a steamship bound for New York with 4 cents in his pocket, the clothes on his back, a book of poetry, scientific article he had written, and designs for what he believed would revolutionize electrical engineering. As the ship departed from European shores, Tesla could not have imagined that he was sailing toward both the greatest triumphs and the most devastating disappointments of his life, toward a collision with the man who would become his greatest rival, toward breakthroughs that would transform civilization, and toward a lonely death in a hotel room, nearly 6 decades later. However, this was only the beginning of a story that would see an immigrant with nothing but genius and determination challenge the most powerful industrialists of the age, unlock forces of nature that others declared impossible, and come heartbreakingly close to achieving a vision so radical that even today, more than a century later, it seems like something from science fiction rather than history. Tesla arrived in New York City in 1884 with virtually nothing, but was immediately hired by Thomas Edison after presenting his letters of recommendation. Edison, then at the height of his fame and power, had built a vast business empire around direct current electricity, with power stations operating in New York and other major cities. The two men could hardly have been more different. Edison was a practical, business-minded inventor who approached problems through trial and error, famously testing thousands of materials before finding a suitable light bulb filament. Tesla, by contrast, was a theoretically trained engineer who solved problems through mathematical calculation and mental visualization. Edison worked with large teams and understood the commercial implications of every invention. Tesla preferred solitary contemplation and cared little for business considerations. Despite these differences, Tesla initially impressed Edison with his work ethic and problem-solving abilities. Edison's DC generators and systems were plagued with inefficiencies and frequent breakdowns, and Tesla volunteered to redesign them completely. According to Tesla's later accounts, Edison promised him $50,000, an enormous sum equivalent to over $1 million today, if he could improve the generator designs. Tesla threw himself into the work with characteristic intensity, working nearly 24-hour days and ultimately delivering 24 different designs that significantly improved the efficiency, output, and reliability of Edison's DC systems. However, when Tesla completed the work and requested his payment, Edison reportedly laughed and dismissed the promise as a joke, saying, "Tesla, you don't understand our American humor." Whether this exchange occurred exactly as Tesla described, or whether the promise was misunderstood or exaggerated in retrospect, remains historically debated. What is certain is that Tesla felt betrayed and humiliated. When Edison later offered him a raise of $10 per week, from $18 to $28, Tesla was insulted by what he viewed as a pittance and promptly resigned in 1885, barely a year after arriving in America. The period following his departure from Edison's company proved to be perhaps the darkest of Tesla's life. For more than a year, he struggled to survive in New York, working as a manual laborer digging ditches for $2 per day, a humiliating occupation for a man with his education and abilities. He lived in flop houses, went hungry, and watched his grand visions of alternating current systems fade into desperate poverty. Years later, he would describe this period as so painful that he could barely bring himself to recall it. The contrast between his vast intellectual capabilities and his circumstances as a common ditch digger seemed to mock his earlier ambitions. However, fortune's wheel eventually turned. In 1886, Tesla's foreman, who had learned of his background, introduced him to Alfred S. Brown, a superintendent at Western Union, and Charles Peck, a New York attorney. These men, recognizing genius when they encountered it, agreed to provide financial backing for Tesla to develop his inventions in exchange for sharing the patent rights. They established the Tesla Electric Company in April 1887 and provided him with a laboratory at 89 Liberty Street in Manhattan, finally giving him the resources to transform his mental visions into physical reality. Working with manic intensity in his new laboratory, Tesla rapidly developed an entire system of alternating current generation, transmission, motors, and transformers. Between 1887 and 1888, he filed for more than 30 patents covering every aspect of polyphase AC systems. These were not incremental improvements, but revolutionary reconceptualizations of electrical engineering. His AC induction motor contained no brushes or commutators, the sparking mechanical components that plague DC motors, instead using rotating magnetic fields to induce motion in the rotor through electromagnetic induction. The elegance and efficiency of the design were breathtaking. In May 1888, Tesla was invited to present his findings to the American Institute of Electrical Engineers in New York. His lecture, titled "A New System of Alternate Current Motors and Transformers," was a sensation in engineering circles. The audience included many of the most prominent electrical engineers in America, and Tesla's demonstration of working motors running on polyphase alternating current, which had been declared theoretically impossible by his former professor, stunned the assembled experts. News of the lecture reached industrialist George Westinghouse in Pittsburgh, who immediately recognized the revolutionary implications of Tesla's system. George Westinghouse was Edison's greatest rival in the emerging electrical industry. While Edison's direct current systems could only transmit power economically over distances of about a mile, limiting installations to dense urban centers, Westinghouse had been promoting alternating current systems capable of transmitting power over much longer distances. However, he lacked an efficient AC motor, the final piece necessary to create a complete AC electrical system. Tesla's polyphase motor solved this crucial problem. In July 1888, Westinghouse traveled to New York and negotiated an agreement to purchase Tesla's AC patents for $60,000 cash, plus 150 shares of Westinghouse Electric stock, and a royalty of $2.50 per horsepower of AC motors sold. If fully realized, this royalty arrangement could have made Tesla one of the wealthiest men in America. Westinghouse also offered Tesla $30,000 per year, an enormous salary for the era, to work as a consultant in Pittsburgh, helping to adapt his designs for commercial production. Tesla relocated to Pittsburgh but found the experience frustrating. Westinghouse's engineers, trained in different methods and skeptical of this foreign newcomer's revolutionary ideas, resisted many of his suggestions. Factory management insisted on modifications that Tesla believed compromised his designs. Accustomed to working alone with complete control over every detail, Tesla chafed under the collaborative, commercially driven atmosphere. After approximately 1 year, he returned to New York to establish his own laboratory, though he continued collaborating with Westinghouse on the development of AC power systems. What followed was perhaps the most contentious technological battle in American history, the so-called War of the Currents. Thomas Edison, recognizing that Tesla's AC technology threatened his entire DC-based business empire, launched a vicious public relations campaign against alternating current. Edison and his representatives staged public demonstrations in which animals, including dogs, cats, and even an elephant named Topsy, were electrocuted with AC current to demonstrate its dangers. Edison's associates promoted the electric chair for executions, specifically insisting it use Westinghouse's AC current, so that Westinghousing might become synonymous with electrocution. Newspaper articles sponsored by Edison's interests claimed that AC current was inherently dangerous and unsuitable for homes or public use. Despite this propaganda assault, Tesla's technology possessed overwhelming technical advantages. Alternating current could be transmitted efficiently over long distances, using transformers to step voltage up for transmission and back down for safe utilization, something impossible with direct current. As cities expanded and the demand for centralized power generation grew, the limitations of Edison's DC systems became increasingly apparent. The conflict reached a decisive turning point when the Niagara Falls Commission, established to harness the enormous power of Niagara Falls for electrical generation, evaluated proposals from Edison and Westinghouse. In 1893, Westinghouse, using Tesla's polyphase system, won the contract to light the Chicago World's Fair, the Columbian Exposition, providing spectacular demonstration of AC power's capabilities to millions of visitors from around the world. That same year, the Niagara Falls Commission awarded Westinghouse and Tesla the contract to build the world's first large-scale hydroelectric power plant. Construction began immediately on a system that would eventually power the growing industrial city of Buffalo, New York, 22 miles away, a distance that would have been impossible using Edison's DC technology. Little did anyone know that, as Tesla stood on the threshold of complete vindication and potential vast wealth, the seeds of his greatest disappointments were already being sown. The triumph at Niagara Falls represented not the beginning of unlimited success, but rather the high water mark before a tide of financial disaster, technological frustration, and personal eccentricity that would eventually leave him impoverished and forgotten in the very city where he had achieved his greatest successes. The period between 1891 and 1899 represented the apex of Tesla's career, a golden age of productivity and recognition during which he developed inventions that would fundamentally reshape human civilization. Working from his New York laboratory, first at South Fifth Avenue and later at East Houston Street, Tesla created what he called his magnifying transmitter, the now famous Tesla coil. This device could generate alternating current at extremely high voltages and frequencies, producing spectacular electrical discharges and, more importantly, laying the groundwork for radio transmission and numerous other applications. Public demonstrations of his Tesla coil, in which millions of volts crackled through the air, and Tesla stood unharmed in the midst of electrical arcs that would have killed anyone using conventional equipment, made him a celebrity and drew audiences of amazed scientists and fascinated journalists. During this period, Tesla conducted pioneering work in multiple fields simultaneously. He experimented extensively with what he called shadowgraphs, images produced using penetrating radiation that we now know as X-rays. In fact, Tesla was producing X-ray images months before Wilhelm Röntgen's famous announcement of their discovery in 1895, though a devastating laboratory fire in March 1895 destroyed much of Tesla's early X-ray work and documentation. Tesla also investigated the biological effects of X-rays, noting that prolonged exposure caused burns and tissue damage, observations that contributed to early understanding of radiation hazards, though Tesla himself suffered damage to his hands and eyes from his experiments. His contributions to radio technology were equally profound, though they would become the source of bitter controversy. In 1897, Tesla filed for ULA patents on fundamental radio apparatus, including the basic system for wireless transmission and reception using tuned circuits, the foundation of all radio communication. These patents were granted in. Tesla gave public demonstrations of radio-controlled boats, including a dramatic exhibition at Madison Square Garden in 1898, where he operated a small vessel by wireless command, predicting that such teletomaton devices would revolutionize warfare and industry. The audience, unable to comprehend how the boat operated without physical connection, suspected trickery, or even that a trained monkey was hidden inside. However, Tesla's vision extended far beyond mere communication. He had conceived something vastly more ambitious, nothing less than a worldwide wireless system that would transmit not just information, but actual electrical power through the Earth itself and the atmosphere. Tesla believed, based on his understanding of resonance and wave propagation, that the Earth could be used as a conductor, and by establishing standing waves in the planet's electromagnetic field, he could transmit unlimited amounts of electrical power to any location on the globe without wires. To anyone else, this notion seemed like madness. To Tesla, it was simply applied physics. In 1899, Tesla traveled to Colorado Springs, where he established an experimental station specifically to test his theories about wireless power transmission. The location was chosen for its high altitude, dry atmosphere, and frequent lightning storms, natural electrical phenomena that Tesla intended to study and harness. He erected a laboratory containing the largest Tesla coil ever built, with a coil measuring 52 feet in diameter and a 42-foot metal mast mounted with a copper sphere. This device could generate voltages approaching 100 million volts and produce artificial lightning bolts that extended more than 130 feet from the tower. The experiments Tesla conducted in Colorado Springs were both magnificent and terrifying. He deliberately triggered bolts of artificial lightning that could be heard thundering 15 miles away. Witnesses reported seeing Elmo's fire dancing on metal surfaces, sparks jumping between their feet and the ground as they walked, and electrical discharges from water faucets when touched. Butterflies flying near the laboratory glowed with electrical luminescence. Tesla claimed he could light electric lamps planted in the ground at distances of over 1 mile from his transmitter, though documentation of these claims remains somewhat ambiguous. On one occasion, his experiments overloaded the entire dynamo at the El Paso Electric Company power station, plunging Colorado Springs into darkness and infuriating the power company manager, who demanded compensation for the damaged equipment. During the 9 months Tesla spent in Colorado Springs, he filled hundreds of pages of notes with detailed observations of atmospheric electrical phenomena, calculations of Earth resonance frequencies, and designs for increasingly ambitious wireless power systems. He convinced himself that he had confirmed his theories about wireless power transmission and that the Earth exhibited natural electromagnetic resonances, what would later be rediscovered and termed the Schumann resonances, that could be exploited for power transmission. His notes from this period reveal both genius and a troubling tendency toward overconfidence in conclusions drawn from ambiguous experimental data. Returning to New York in 1900, Tesla sought financial backing for his most ambitious project yet. He approached the legendary financier J.P. Morgan with a proposal to build a world wireless system for global communications. Morgan, intrigued by the possibility of controlling international communications, provided $150,000 in funding in exchange for 51% ownership of the patents. With this capital, Tesla purchased 200 acres in Shoreham, Long Island, and began construction of Wardenclyffe Tower, a massive structure that would serve as the prototype transmission station for his worldwide wireless system. The Wardenclyffe facility featured a 27-foot tower, topped with a 55-ton metallic dome, erected above a specially designed underground structure, with iron pipes driven 300 feet into the earth to establish proper grounding. Tesla envisioned this as merely the first of dozens of such towers that would eventually span the globe. However, he made a critical miscalculation in his dealings with Morgan. He had presented the project primarily as a communications system competing with Marconi's transatlantic wireless telegraph. Morgan was interested in communications monopoly, not electrical power distribution, which he viewed as a competitive threat to his existing investments in copper mining and conventional power systems. As construction progressed, Tesla's actual intentions became apparent. Wardenclyffe was not merely a communications tower, but a massive electrical power broadcasting station intended to transmit unlimited free energy to anyone with an appropriate receiving device anywhere on Earth. When Tesla requested additional funding to complete the project, Morgan demanded to know why the tower had grown far beyond the original specifications. Tesla explained his true vision: wireless power transmission that would make traditional power lines obsolete and provide electricity as freely as air. Morgan, recognizing that free energy meant no mechanism for metering and charging customers, refused to provide another cent and effectively blacklisted Tesla among other potential investors. By 1905, construction at Wardenclyffe had ground to a halt, incomplete. Tesla, having invested his own funds beyond Morgan's initial backing, found himself deeply in debt with a partially built tower that could neither fulfill its intended purpose nor attract new investment. The facility stood as a monument to visionary ambition exceeded by financial reality. Marconi, meanwhile, achieved the first transatlantic radio transmission in 1901, claiming credit for inventing radio, despite using 17 of Tesla's patents in his system, a theft that would not be legally resolved for decades. The failure of Wardenclyffe marked the effective end of Tesla's career as an active inventor of major innovations. He continued proposing new ideas, including bladeless turbines, vertical takeoff aircraft, and what he cryptically called a death ray for national defense. But increasingly, these were announced through press releases rather than demonstrated through working prototypes. As we will see, the period following Wardenclyffe's collapse would transform Tesla from a revolutionary inventor into an increasingly eccentric public figure, progressively disconnected from both scientific reality and financial solvency, sliding toward a lonely conclusion that seemed to mock the brilliance of his earlier achievements. The years following the Wardenclyffe failure marked Tesla's gradual descent from celebrated genius to marginal figure, a trajectory made more tragic by his continued brilliance in a world that had moved beyond his ability to fund his visions. In 1916, facing insurmountable debt and with creditors demanding payment, Tesla was forced to declare bankruptcy. In 1917, the Wardenclyffe Tower was dynamited and sold for scrap to partially satisfy his debts, a literal demolition of his grandest dream. The property was foreclosed for a man who had once stood on the verge of transforming global civilization. This represented a humiliation almost beyond bearing. Tesla's financial deterioration was matched by increasingly eccentric behavior that alarmed those who remembered his earlier achievements. His obsessive-compulsive disorder, always present but previously manageable, intensified dramatically. He became fixated on the number 3 and multiples thereof, compulsively walking around buildings 3 times before entering, using exactly 18 napkins to clean his silverware before every meal, and staying only in hotel rooms with numbers divisible by 3. He developed severe germophobia, refusing to shake hands and displaying visible distress when in proximity to people with colds or other illnesses. His aversion to pearls and round objects intensified to the point that he could not bear to be in the same room as a woman wearing pearl jewelry. From the 1920s onward, Tesla lived in a succession of Manhattan hotels, typically occupying luxury suites far beyond his means, and inevitably moving on when unable to pay the bills, leaving behind trunks filled with papers, equipment, and unpaid invoices. The hotels tolerated him partly from respect for his past reputation, and partly from hope that his fortunes would somehow reverse. He maintained a facade of dignified poverty, dressing impeccably in tailcoats and white gloves, even as he subsisted on meager meals and owed money throughout the city. Occasionally, former admirers or Westinghouse executives would provide small stipends, ostensibly as consulting fees, but actually as charity to prevent complete destitution. Perhaps most poignant was Tesla's relationship with pigeons, which dominated the final 2 decades of his life. He began feeding pigeons in Bryant Park and eventually developed an intense attachment to a specific white female pigeon, which he claimed visited him regularly at his hotel room window. Tesla would walk to the park daily regardless of weather, spending what little money he had to purchase feed, and grew increasingly convinced that he shared a mystical connection with his favorite white pigeon. "I loved that pigeon as a man loves a woman, and she loved me," he later confessed to friends. "As long as I had her, there was a purpose to my life." When this particular pigeon died in 1922, Tesla was devastated, claiming that at the moment of her death, a brilliant light emanated from her eyes, a light he interpreted as a sign that his life's work was complete and nothing remained to be accomplished. This statement, coming from a man who had once aspired to provide unlimited free energy to the entire world, reflects both the depths of his loneliness and the degree to which isolation had distorted his perspective. The inventor, who had corresponded with the leading scientists of his era, who had been feted at society gatherings, who had counted Mark Twain among his friends, had become a solitary figure whose most meaningful relationship was with a bird. Despite his increasing marginalization, Tesla continued issuing press releases, announcing fantastical new inventions. He claimed to have developed a death beam, a particle beam weapon, capable of bringing down entire squadrons of aircraft from hundreds of miles away and rendering war obsolete through its deterrent power. He announced designs for geothermal energy systems, methods to split the Earth like an apple using resonance vibrations, and systems to communicate with extraterrestrial intelligence. These announcements grew increasingly grandiose and less tethered to demonstrable reality. The press, which had once reported his claims with respectful attention, now treated him as an eccentric curiosity, interviewing him on his birthday each year as journalists might cover an aging celebrity. With affection mixed with condescension, his rivalry with Thomas Edison never fully resolved. Even as both men aged, the fundamental clash between their approaches, Edison's practical empiricism versus Tesla's theoretical idealism, represented an unbridgeable philosophical divide. In 1915, rumors circulated that both men would share the Nobel Prize in physics, but the prize went to neither, and speculation suggested that each had refused if the other were to be honored jointly. Whether this account is true remains disputed, but it reflects the genuine animosity that persisted between them. In 1934, at age 78, Tesla moved into the New Yorker Hotel, occupying rooms 32T7 and 32T8 on the 33rd floor, numbers properly divisible by 3. The hotel provided these accommodations through an arrangement with Westinghouse, which again supplied a modest stipend on humanitarian grounds. Tesla's daily routine became ritualized and invariant, rising early, walking to the park to feed his pigeons, returning to his rooms to work on calculations that filled thousands of pages, but led to no completed inventions, occasionally receiving journalists who requested interviews with the eccentric mad scientist. On January 7, 1943, Nikola Tesla died alone in room 327 at the age of 86. The maid found his body after he placed a "Do Not Disturb" sign on his door that remained for 3 days. The assistant medical examiner determined the cause as coronary thrombosis, essentially a heart attack. An estimated death had occurred at approximately 10:45 p.m. on January 7. Tesla died as he had increasingly lived in solitude, surrounded by papers detailing inventions and theories that would never be built. His vast mind finally stilled by the simple biological failure that awaits all mortals regardless of genius. The aftermath of Tesla's death sparked immediate controversy. The FBI seized all his papers and possessions from his hotel room. Concerned that his claimed death beam designs might fall into enemy hands during World War II, his notes were examined by Dr. John G. Trump, an MIT professor and uncle of future President Donald Trump, who concluded that Tesla's papers contained no workable designs for weapons or revolutionary devices, only primarily speculative, philosophical and promotional materials. In 1952, Tesla's remaining possessions were returned to his family in Yugoslavia, where they formed the foundation of the Nikola Tesla Museum in Belgrade. 6 months after Tesla's death, in June 1943, the US Supreme Court issued a ruling in Marconi Wireless Telegraph Company via United States, invalidating 4 of Marconi's key radio patents and acknowledging that Tesla's patents had priority. Ironically, this legal vindication came decades too late to provide Tesla financial benefit or public recognition. The court's decision was partly motivated by the US government's desire to avoid paying patent royalties to Marconi's company for military radio use during World War I, but it nonetheless represented belated acknowledgement that Tesla, not Marconi, had invented the fundamental principles of radio communication. Tesla's legacy has undergone remarkable rehabilitation in the decades since his death. While he died in relative obscurity, dismissed as an eccentric whose later years tarnished his earlier achievements, modern evaluation recognizes him as one of history's greatest inventors. The alternating current systems he developed power virtually every electrical device in the modern world. His patents underlie not only electrical generation and transmission, but also radio, remote control, wireless communications, and numerous other technologies taken for granted in contemporary life. The SI unit of magnetic flux density bears his name. The Tesla, ensuring that every physics student encounters his contribution to science. The man who attempted to wire the world to lightning never achieved his ultimate vision of wireless global power transmission. Modern physics has confirmed that while Tesla's understanding of electromagnetic phenomena was profound, his specific theories about conducting electricity through the Earth itself were based on incomplete understanding of how electromagnetic waves propagate. Wireless power transmission of the sort he envisioned would require energy densities dangerous to biological organisms and would be phenomenally inefficient compared to conventional transmission lines. Yet this failure of his grandest ambition should not obscure the magnitude of his actual achievements. What do you think of Nikola Tesla? Was he a tragically overlooked genius whose revolutionary vision was simply too far ahead of its time, or an increasingly delusional eccentric whose later grandiose claims undermined legitimate earlier contributions? Was his fate a cautionary tale about the importance of practical business sense to complement scientific genius, or an indictment of a society that rewards only those inventions with immediate commercial applications? Please let us know in the comments section, and in the meantime, thank you very much for watching.